Okay, good afternoon. So I'm Ashin. So recently I started to get interested in evaluations, all right? So then that's why I choose this topic to talk about challenges in evaluating interactive recommender system. Okay, so first of all, RecSys is not a understudied topic. In fact, it's a very, very well-studied topic in the sense that we see the first survey paper happens, or the most influential survey paper happens in 2008, the TKD survey paper, all right, which is about 15 years ago. And that's the first survey paper. And from then onwards, we start to have a good number of papers. So this is the number of papers per year, not the total, not accumulative, it's per year, all right? So last year we got nearly 4,000 papers. And in fact, last year we have 28 survey papers in that year. So recommender system is very well studied problem, right? But still, for the benefit of the audience, I just try to provide a picture. What does it mean by a recommender system, all right? So we have users, and user, of course, will interact with the system. It can be a mobile app, can be websites, whatever. So user have actions like buy a item, like a photo, watch a movie, and give a low rating for certain things, dislike, all right? And eventually, your recommender system will try to get all these user feedbacks and try to provide the recommendations to the user, all right? So for a long way, basically in the past, probably 20 years even, we have been formulating recommender system as a kind of matrix. So we have the users here, and we have the items, so it's a matrix. And here we have the positive or negative interactions, all right? And typically, we consider everything is positive. User like this item, or user buy this item, and somehow this could be user give a low rating of these items or whatever. Our job is to predict whether user like this item or not. All right, if this give a very high kind of preference or high level of prediction, we basically put this at the top as a recommendation. So this is basically what we have done in the past. All right. So when you approach me to see, come to give a talk and see what's the workshop about, he mentioned that it's an interactive RecSys. I have been working in RecSys for long, probably more than 10 years. All right, but this is still new to me. What does it mean by interactive RecSys? So I studied the homepage to learn what does this mean, right? It says that existing RecSys mainly focus on the predicting of user future behaviors, like ratings, clickings, as what I described earlier, right? But they ignore the interactions between the user and the recommender agent. So there's certain kind of interactions, right? I mean, that could be your mouse moving position or your browsing, that kind of interactions, right? So, so interactive recommender system encourages the interactions between the users and recommender agents, and then hopefully we're able to convince the users, or in the sense that we provide better recommendations through understanding the interactions, right? Let's see if the user start to scrolling, that means the top few items are not of his interest. All right. If the user stopping, then probably he's giving a detailed rating of the possible items. All right. So that's kind of an interaction. I also happen to work in information retrieval for a long time, right? So other than this single information source, I do a search as well. And then I find that actually there is a survey paper. This was published in 2016. All right. So this means that this is also about a 10 years old topic. All right. So they have a survey paper on interactive recommender system. And so I try to study this paper and what does it mean by recommender system. So they have a survey here. You see, they have the visualization objectives, visualization techniques, recommender algorithms, and here are all the systems. So it's pretty much they emphasize on the visualization because that is an interface between user and the system, right? So that's basically, I mean, because you want to encourage interaction, of course, you need to provide an attractive interface so that the people are able to interact with you, right? So the actually study propose me how to realize this so that you are able to encourage the users' interaction. So they summarize the whole system in this context. This is just reproduced from that paper, and not my drawing, right? So they have this recommender engine, and they have the user data. So the user data here means the historical interaction. So what the things this user purchased in the past or whatever, that's the user data. So the context is the right now, the context user, let's say the user's location, all right? Maybe user's weather is a wet weather or a sunny weather, and where he is, and so on and so forth. This is very dynamic changing, all right? Then the medium will be the collaborative, the user history. So I have this user's history, I have all the other users' history. This is from where I'm able to infer users' preference. And based on the context, I'm able to adjust the kind of recommendation, right? So you have a recommendation engine and they provide the things, okay? So this is basically the whole idea. And so the interactions, those kind of curves, right? This refers to the interactions across the different data elements, right? Then the thing is that then after reading this, I kind of try to think, what does it really mean by interactive RecSys? So is it just a typical recommender system plus a kind of realization, right? So let's look at what's the utmost goal of RecSys in general before we look at interactive, right? So in general, it's basically we try to predict and answer users' latent information need. So of course, this information need can be generalized as what kind of a need, all right? So this is like latent because it's hidden to us. We try to predict the user preference. And this just as what Lisa mentioned is intent, the user's intent, all right? So it's a latent information needs. We try to predict, and this is what you want, I try to answer that. So this is general, all right? So the shifting from general RecSys to this interactive RecSys is try to explain why the current recommendations are generated in this manner from the system point of view, because I have all my historical data, I have users data, I have other users data. Now I also have your context. So that's why I predict your interest in this way, right? So try to in that way. And try to incorporate users' feedback. This feedback can be the scrolling of screen and whatever this kind of interactive features to adjust, right, for users' good. Then finally, the goal is that you need to buy my product. That's the final goal, right? So if you look at the final goal, it actually doesn't differ much from the general recommendation. It's just that you provide another way in the sense that to let the user have some kind of control, have some kind of feedback so that I can answer your queries better. So, but all this, the survey paper or even this workshop doesn't mention about the potential cost from the user. So what does it mean by the cost? Is that the cost to understand this validation. So I need to learn your user interface and learn how to provide feedback. So this is a user's cost, all right? And also it doesn't consider the cost of understanding the way to interact with the system, okay? So ideally, recommender system, if the system is good enough, it should predict the items which I'm interested in the top position. I click it, pay it, that's it, right? That's the ideal situation. So now I need to interact with the system. So any click, any single word I provided is on the user's cost. So this is my cost, right? So basically any single click from a user is a cost from a user, okay? So basically I always believe that laziness is the first motivation for innovation, all right? Because I'm lazy, I don't want to do this. That's why I want to invent a simple system, auto system to do that, okay? So if you consider from this way, the user interactions can be considered as a form of query reformulation. If you look at from the search engine point of view, I give a query, I do not get what I want, but I see these are current results. I rephrase my query, right? So this is similar, okay? And this one is also a very important cost. The thing is that you see, most of the demo system we see in the conference, in many cases, we see graphical interface. We see graphs, some nodes, some links very often, right? And so far, very, very few commercial websites show that kind of interface. You think about all the interfaces you've seen, they don't use graph interface. You have a node, you have a link, and dynamically adjust whatever, seldom, right? But if you look at conference demos, you see that very often, right? The reason is that for this kind of graph, you have nodes, they are not predefined. The nodes can appear anywhere. The edges may connect and the same. They may have their own semantics. Actually, it gives very high cost for the user to interpret that, right? So it's very difficult in the sense. Just to stop me when the time is up, huh? I don't look at the time. Okay, so then when I see this is the user cost, right? On top of a general recommender system. So we need to look at, is it a challenge to evaluate a typical or general recommender system? And after we understand that, we will consider to add additional cost from the user side, right? And this is taken from another survey paper very recently published in TOIS. Sorry, is it TOIS or ECM computing survey? Either one should be computing survey. So they give a framework to look at the evaluation objectives, the principles, the online, offline evaluations, and different evaluation perspectives. So it's a very complex issue, right? So as I mentioned, to evaluate interactive RecSys, we'll be handling all these issues plus the user cost. And that will be the challenges to evaluate interactive RecSys, okay? Then we go back to the fundamental things. Are we evaluating our generic models in a practical way? Okay, so in the past, are we evaluating in the right way or somehow not so right? Okay, so we look at this problem again, and we have a matrix, and we have the records, and we try to predict the empty cells, and that's a preference. All right, so what we do is that we hide some of these known interactions, and we try to predict because these are the ground truths. And we predict and compare against the ground truth, okay? But we seldom consider how do we actually reach this status, how the data was collected, and is how these records are collected, right? And when does the recommendation really happens? Because that matters. That is the point we need to tell whether we fulfill the user's need or not. We try to predict users' the intent to request and try to answer, but that happens at a particular time, all right? So if you look at this, it actually takes time to accumulate all the records, okay? For example, movie lens data you're using, that is a record for 10 years. Yelp data you're using, that's a record for 10 years. Amazon data you're using, more than 10 years, okay? The time span of data collection. So all this is more than 10 years of data putting into a matrix, and then we do the prediction. So what's the issue with that? The main issue is that we somehow focus too much on the model. We didn't look at the whole picture at the system, okay? Because eventually, in reality, what's serving us is a system, and we are looking at the model itself, okay? So let's go back. In reality, what kind of recommendation they have? The simplest one. Popularity, right? Very, very simple, straightforward, even there's no model, it's just popularity. So this is the New York Times bestsellers, and they publish this every week. So this is the most popular books in this week, all right? Of course, you want to see the monthly list, you can click, it's a monthly, all right? And this one is Amazon popular, and they update this list in hourly basis. So this is the most selling products in the past hour, the trending, okay? So when does a RecSys really happens is that, let's say this is a time, it's just a time. And this is user, and this is user interaction. Let's see the things this user buy, right? And this is basically user interaction history we have. This is another, the user interaction history we have. And this is the current time. So when the user come to visit system, we provide a list of items, and you may like this. A user may click, and this becomes another interaction. Okay, so this is clear, right? Simple illustration. But what we do in reality for our academic evaluation is that we need to somehow formally define our problem. given this is data, and our task is to predict what, and this is true, this is false, and this is the accuracy, and this is the precision recall, this is, right? So in order to do that, we basically, of course you can do online, but most people don't have this luxury to have online system to evaluate algorithm. To be very frank, yeah, we published 4,000 papers, right? There's not 4,000 experiments running. So most of you will do offline evaluation. To do offline evaluation, you need to partition the data as train and test, right? How do we partition? This is one of the typical way of partition, leave last one out, right? I have all the users interaction, except the last one is training, the last one is test. So I have your history, I try to predict this, okay? Similar for this one, I have your history, I try to predict this one. But if you put them into the time, it looks like this, all right? So at this time point, I try to predict this. I know, of course, U1's information. I only know U2's one information. I have no idea of what's going to happen in the future with respect to this time, right? Because you are predicting at this time, okay? Then we look at how we define popularity in our papers. The popularity set, the most frequent items in the training set. So what's the most frequent item in the training set? This is the training set. I get the most popular items, and that's the prediction. So in order to predict this, I will rank all the items based on your frequency in the training set. Happen that something here is very, very popular, you're going to recommend this item to this point. So you get the point? Yeah. So we can see the difference between popularity in practice. The ranking is dynamic because it's an hourly list, it's a weekly list, it's a monthly list, right? And the ranking is based on the interactions within a very short time period, an hour, a day, a week, a month in the past, all right? But for the popularity in your research, which will often serve as a baseline, right? We often need to see that my model is better than popularity. This is a minimum requirement, right? If you cannot beat popularity, then what's the model about, right? So we have our popularities. The ranking is a global static ranking, doesn't change, okay? So the ranking is derived from the entire training set, okay? So the thing is that why we derive the popularity in this way, and somehow we know that it's probably not that right? Because we want to have a fair evaluation. The fair evaluation is that because all machine learning models are trained in that way, okay? We have the training data, we have the test data, we feed in the training data to the machine learning model, and we try to get the prediction. Our popularity, this one, is considered as a very, very shallow or trivial machine learning model. We do the same, right? And this also means your machine learning models are evaluated in the wrong way. You get the point, all right? Because you train your model using this data, and you're trying to predict an instance happening here, all right? Okay, so is this a very significant issue? So let's look at our data set. This is a moving length data set, 25 million. And the data set actually lasts more than 10 years. So we just take a 10-year time period, okay? So the blue circles are number of movies that received its very first rating ever. So let's say a movie somehow here received the very first rating. We may assume that this is the time the movie got released, all right? So this is another, maybe this is somewhere Titanic, and this is Avatar, and so on and so forth, all right? And then how about this brown dots? This is the number of users whose last interaction happens. Last interaction, okay? So the user's last interaction may happen here. Movies may be released here, but still we are using a lump sum to train a model, to evaluate a model, right? So does this reflect the reality? Very unlikely, okay? And this is the Yelp data. This is Amazon Electric's data. this Amazon Music data. So basically, we know the music, new songs released from time to time, right? And users stop using this platform from time to time, but yet we put them into a static data set and do the evaluation, right? And you may consider that it probably doesn't affect our results, but if you consider that, given the time, I say I don't have time to give a detailed illustration this. If you're interested, you can read my paper, right? I want to move to the second point. How many time I have? Maybe another 5 minutes. Okay, so we might want to go back to the origin of the recommender system. Okay, the very early origin, when we start to use the term collaborative filtering. What does this mean? All right, so we go back to the history, and the first paper proposed the term collaborative filtering was 1992. Okay, so this is a system by IBM. Okay, so the report, I'm not sure how to pronounce this, tapestry. So this system, it's a system that designed to support both content-based and collaborative filtering to support the user, basically news rating, okay? So what does it mean is that, suppose this is user, suppose I want to read some interesting news, but I don't have the time to go through all the news, right? But I know David, I know Grace, they share similar interests with me. So because David read the news, will put a flag, this is interesting news, and this is not interesting news. And Grace also read the news and put a flag, this is interesting news, all right? Then as long as I know them have a similar interest as me, I subscribe David and Grace reading. So whenever they leave a message, see this is good, I will read this news, all right? And if you think about this, it's basically user trust the recommendation by the self-selected experts. So I know this guy have a similar interest with me, and that guy have a similar interest with me, so I trust their decisions, okay? So in the sense that it's very similar to the way we're interacting with Twitter and Facebook. So you find this account is interesting, you follow, and then all the things posted or retweeted by this guy will come to your feed, right? And you choose who to follow, okay? So right now, we are not doing that. We are using a system based on the user item interactions to infer which kind of interest you like, all right? So this is fairly different from, because initially users have the power to choose who to follow. Now you don't have that. System will choose, and whether the system chooses it right or wrong, we do not know, all right? And this is probably why an interactive may be a good approach to let the user to have some kind of control, okay? But on the other hand, we can also see that in the past system, when I choose the users, I trust his decision-making process rather than trust the items. You get the point? He shares similar interests. When he reads these news articles, his decision will be similar to my decision. I trust his taste in the sense, all right? So now, what we are trying to infer is that if these two guys buy the same thing, they have the same taste, all right? And then we need to look at, let's see, this is the time when the iPhone was first released. There will be a group of people, die must buy the iPhone, right? Regardless of what, I'm queue up midnight to buy the iPhone. Right? The first day, I just queue up midnight. I wait for 8 hours, I'm the first user to the iPhone, right? And this is the group of people know that the next version is going to launch, and the current version will have a price drop, right? I need to, at this point, I catch the tail, right? Because 2 months later, it may just off shelf, right? So this is the person who have that. And this somehow, someone lost a phone, and you must buy one in the middle, right? And then the alternative models or the kind of choices, the decision process will be different from this and very different from this. Okay, let's say today you somehow lost your phone. within a day you must buy a phone. There's no choice. So you have to look at this. Okay, there's only 5. Among the 5, I choose this one. Right? You don't have the luxury to say that I will wait for the next launch of iPhone or I wait for the next. It's different. So your decision context will be very different at different time. All right. So my argument is that even if 2 users interact with the same item, it doesn't mean that they share the same process because you're not modeling the decision process. It's just like you have the buffet lunch. Just now you went to the restaurant. You only have these few choices. You have to pick up something, right? So end of the day, you see this guy pick up a noodle. It doesn't mean that he really prefers noodle because this is the only choices I have at this time point, right? So my decision is based on what is available at this particular time and somehow my preference. So if we know this, the kind of context, it probably provides us much better, right? But once you put everything into a matrix, you don't have this at all, okay? So to my understanding, I know this workshop is not like a few hundred people listening, right? To my understanding is that we are formulating the problem in the wrong way, okay? And that's why the results we get may not be that correct as well. And that's why the results we get in the academic papers may not be reproducible in practice, okay? So can we do it better? Evaluating RecSys is extremely challenging, all right? Consider all the things we mentioned. And we need to consider the model accuracy. We need to consider the business KPIs. And this includes two parts. One is that we need to increase the volume, increase the revenue, and we also need to cut down the cost. We cannot somehow change the entire system overnight. So there's a lot of things you need to consider, all right? And there's also impact from the website design, from the existing models, from many other factors, okay? So it's not as simple as we train a model and we see our model is better than yours, all right? So we also need to consider what does it mean by a fair comparison. Fair comparison means that as long as I provided you a fair condition, that means a fair consideration. So what does it mean is that I can use a popularity at this time. The popularity could be just using the past week's data. Of course, you can use your machine learning model, use all the historical data. As long as both of them have access to that, it should be fine, right? Because my popularity get the best result using the past week's data instead of past month's data or past year's data. So why force me to use all the data? I should use the past week's data, right? For your machine learning model, and you can get the best results using the past month's data, then you use, because as long as the past data, everyone can access, you can choose whatever data you need for the best accuracy, right? So that's a fair kind of another way of understanding fair evaluation, okay? So I shouldn't take too much time. Thank you.